Sound levels are measured in decibels. 100 decibels is loud, and 10 decibels is really quiet. Shh. Unfortunately, it's just not that simple. In this segment, we're going to learn just a little bit about sound pressure, audio energy, loudness, and how to measure it. It's not going to be all hot air in theory, however, as we jump into a digital editing environment and show you where your levels need to be for recording, mixing, and mastering. Get ready because we're going all the way to 11 on this segment of TechKnow. There are loud sounds and there are quiet ones, and it's common knowledge that the loudness is measured in decibels. Whenever the topic comes up in a textbook or on the net, you'll often find a chart of the relative loudnesses of some common sounds. This is all well and good as a way of orienting someone to the decibel scale. 0 decibels is quiet and 100 decibels is very loud. When you really scrutinize the chart, however, it's got to cross your mind. How did they decide that a vacuum cleaner was 70 decibels? Whose vacuum did they measure? How far away did they place the microphone? And who exactly are they anyhow? Let's start at the beginning. Sounds are essentially the jostling of air molecules into sound pressure waves. The device we'll use to detect the changes in the sound pressure levels is, of course, a microphone that has a diaphragm in it that moves back and forth, in this case past a coil of wire. This induces a tiny electrical current which we can measure, amplify, and record. We can measure the tiny electrical current generated by the microphone with any voltmeter. A traditional analog audio levels meter can be thought of as a special voltage meter, or as a volume meter, or as a volume indicator, or you can just call it a VU meter, since we're going to perform our measurement in terms of volume units. A volume unit is a completely arbitrary unit like degrees Celsius or degrees Fahrenheit. As long as everyone agrees and uses the same units, we can compare the relative sound pressure levels of anything that makes a noise. Of course, all of the meters in the world would need to be calibrated properly to some reference. That's what this mark on the meter is. Once we have this reference, we can express all other sounds in terms of a ratio relative to this 0 point. Everything below it has a negative ratio, everything above it is positive. When the input sound pressure level equals the reference, the ratio is 0. The volume unit scale might run from -20 to 0 to +3, but it could be different. For example, having a little more headroom on the top. Interestingly, this isn't a linear scale, but then again, our perception of loudness is not linear to the actual sound pressure levels anyhow, so it all works out in the end. Since this is an analog meter, the needle bounces around a lot between the peaks and valleys of the sound pressure waves, which makes it impossible to simply take a solid, steady reading. The technique then is to take an average between the peaks and valleys. So for example, let's call this reference level 1 volt RMS, or root mean square. Again, this is arbitrary. It could be 0.775 RMS or anything else, as long as we all agree. The decibel is a different unit of measure from the volume unit. It was invented by the Bell Telephone Laboratory in the early 1920s. The original unit, the bell, was used to measure voltage losses over long distances. At smaller scales, such as with microphone voltages, the decibel, or 1/10 of a bell, is more useful. So the decibel is not just a unit for comparing the ratio between two audio levels. It can be used for comparing ratios of voltages, power, and/or anything else. Digital audio software and digital audio workstations, or DAWs, use digital meters, of course. Digital meters are more flexible than real-world physical VU meters and can be configured in a lot of different ways. Digital meters can even simulate the RMS bounce of an analog meter, although they are more commonly configured to measure peaks. As you can see on these digital meters here, the top of the meter is 0, and all of the decibel measurements are negative relative to this. Anything above 0 is clipped and lost and should be avoided at all costs. So there is a difference between 0 volume units RMS on an analog VU meter and 0 dB on a digital peak meter. I wish I could just tell you that 0 VU RMS equals minus 12 dB peak, but it can't. Depending on how the digital meters are configured, 0 VU could be anywhere from minus 8 to minus 16 dB. With that in mind, let's just say that minus 12 dB is a good target level for recording. A little more, a little less is not a problem. In our editing software, we can modify the output level with volume faders or gain sliders. These typically default to a 0 dB position, meaning that the input signal is neither boosted nor reduced. A plus 3 decibel increase will raise the volume noticeably, and a minus 3 dB decrease will, of course, result in a decrease in loudness. But by how much? Interestingly, a plus 3 dB increase doubles the signal power, but this does not double the perceived loudness. And since we're mixing audio for humans, this is a really important point. By conducting actual experiments in the human perception of loudness of complex sounds like voices or music, audiologists have concluded that a 6 to 10 decibel increase is generally and subjectively perceived to be twice as loud. Once again, we've covered a lot of ground here in just a few minutes. Here are what I consider to be the most important points to take away. 1. The digital meters in most editing environments peak at 0 dB, which is where the equipment clips. 2. Don't ever let your digital meters clip. 3. 0 VU on an analog meter is somewhere around minus 12 dB on a digital meter and is a good target when recording. 4. Don't clip. 5. A 3 decibel increase on your gain sliders doubles the signal power, but a 6 to 10 decibel increase is generally perceived by our marvelously analog brains to be twice as loud. 6. Clipping. Don't do it. 7. Have fun and remember the words of Duke Ellington. If it sounds good, it is good.